Hello everyone, today we will discuss about the unit vectors. A unit vector is a vector that has the magnitude exactly 1 and it points in a particular direction. A unit vector has no dimension and no unit. Its notation is a hat on an alphabet like I, J, K. Here in this diagram you can see that I, J, K are the unit vectors along positive x-axis, positive y-axis and positive z-axis. The magnitudes of the unit vector can be represented as unit vector I modulus is equal to unit vector j modulus is equal to unit vector k modulus equal to 1. Now we will define the vector and scalar component of a vector. In this diagram, you can see that the magnitude of the vector A is represented by a distance OA, and let us say it is making an angle of theta with the x-axis. Now if we draw perpendiculars on OX axis and OY axis from point A, then those will be equal to OM and ON. OM is called as the scalar component of vector A along x-axis and ON is called as the scalar component of vector A along y-axis. Now here if we write a vector A, then we can write it as AXI plus AYJ. Here let us say ON is equal to AX, so it is the magnitude along the x-axis of the vector A, and if we multiply it by a unit vector, then it becomes the vector component of vector A along x-axis. So AXI is the vector component of vector A along x-axis. Similarly, let us say ON is equal to AY. So if we multiply it by unit vector j, then it becomes the vector component of vector A along y-axis. So a vector can be defined in terms of the vector component as well as in terms of the scalar component. Here AXI is the vector component of vector A along x-axis and AYJ is the vector component of vector A along y-axis. Now AX is defined as the scalar component of vector A along the x-axis and AY is defined as the scalar component of A in y direction. Now let us say vector A is making an angle of theta with the OX axis. So in terms of the magnitude, we can write AX is equal to A cos theta, because you know that in the triangle OAM we can find cos theta as AX upon A. So AX will be equal to A cos theta. Now we have written here AX is equal to A cos theta. Similarly, we can write AY is equal to A sin theta. Now if we square of these two equations and then add, then we can find A is equal to root AX square plus AY square. And if we divide this equation by this equation, then we can find tan theta and it will be equal to AY upon AX, or theta is equal to tan inverse AY upon AX. Now the magnitude of vector can be represented as also, and if we define a unit vector, then we can define a unit vector like if we divide by modulus of a vector, then it becomes a unit vector. So we can write it as unit vector A is equal to A divided by modulus of vector A, or we can write it as vector A divided by A. For three-dimensional space, we can represent here the vector R as xi plus yj plus zk. Here x, y, z are the scalar component of the vector R along x, y, z axis, and I, j, k are the unit vectors along x, y, z axis. The magnitude of this vector in three-dimensional space can be written as root x square plus y square plus z square. Similarly, here we can find the unit vector R, and it will be equal to vector R is divided by modulus of a vector. Thank you.